project proposed for my project. The name is SecureNet, a modernized distribution network with VPNs and firewalls and intrusion detection. So here we have provided a network architecture which is configured on Cisco Packet Tracer. Currently it's Cisco Packet Tracer window. So what we have done is we have provided internet service providers, servers, routers and switches for connections. So we'll go through it. First of all, we have two internet service providers. We have chosen to provide two because in case of any redundancy or error, we'll always have a second option and for better connectivity, of course. Then we have the routers, which is the HQ router, which is headquarter router, and server side router. The server side router we are proposing to keep out of the LAN in a separate WAN wide area network, and the HQ router is connected to the local area network, which is this part, and this is our whole network architecture for an organization. This is the server side router which we are externally taking from a wide area network. So first we'll go through server side router. The server side router has a Cisco 2911 router which is connected to the server side switch and various servers like email server, web server, DNS server and DHCP server. The IP addresses are from the range 192.168.21.0/28. Then we have the HQ router, which is our headquarter routers, and this is connected to two multi-level switches. The connection between HQ router and server side router has been secured by IPsec and network address translation, which provides us end-to-end encryption. So whenever there is a packet transfer between these two routers, these will be end-to-end encrypted, and only the sender and receiver can read it, like we see in WhatsApp messages and different message platforms. So the headquarter router is connected to two multi-level switches. The multi-level switch is also called as three-layer switches. Three-layer switches. So the one of the three-layer switches is connected to the VoIP router. The VoIP router is our voice gateway, which provides us connectivity and configuration for the IP phones provided in the network, so that we can communicate between two networks via IP phones. And the two multi-level switches are connected to different departments. So basically, the HQ router and all multi-level switches and VoIP router is a one single LAN local area network, in which we have divided the network into two sub-networks, where in first sub-network we have three departments, which is HR, CS and marketing department, MT department, and the second sub-network is LM department, IT department. So the purpose of which is to communicate between different organization on different levels, but also with the secure method, and so that no one can breach other security. So what we have done for HQ VoIP router, we can see the implementation as we have provided, like we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15 IP phones, and each IP phone has been configured with a phone number. So if I put my cursor here, like it is showing that line number is 402, and similarly here the line number is 413. So these are the mobile numbers or phone numbers for these phones. So if I want to contact between them, like if I go to IT department and I click on one phone, the line number is 404, and in CS department the line number is 402. So if I click on CS phone and I type as 404 to connect to the department, here it is ringing. We can pick it up. If I click, it shows that it is connected. The two departments are connected via phones. So this is one thing which we have done. Another thing is that since we have server-side router in a wide area network separately, we have provided SSH security to them. So none of the LAN network users can access to server side, which we can see, like supposing if a laptop here is trying to communicate with server side, we have ping as SSH -L IP. We'll write the IP address as 192.168.21.1. It is showing that connection has been refused by remote host and they have denied the access. Also, since this is a single LAN, we can communicate between any device. So, for example, if I click on PC here, its IP address is 192.168.20.76, and here I have IP addresses 192.168.20.7. So, if I ping from here, uh, I have already done this one patch. I'll write ping 192.168.20.7. It is pinging, so it might take some time. This is a PC in MK department, and we are communicating with HR department with IP addresses 192.168.20.7. So this is it. And also we have provided a wireless connectivity among using an access point among laptop, tablets and smartphones which are Wi-Fi enabled devices, and it is also showing that the wireless best data strength is 54 Mbps and signal strength is currently 85%. We have also provided DHCP and DNS configuration so that the IP addresses are uh, up, translated translated or based on dynamically, and uh, for transfer of packets we have used OSPF protocol. So for OSPF we can check here that what are the networks connected in OSPF. One second. It is, if we want to see that what are the routes for the packet transfer, we can do it as do show IP OSPF neighbor. So these are the IDs and the path where if we send a packet, the path it will take. So these are the IP addresses for different paths, and these are the neighbor IDs which we have given as 1.1.1, 2, 3. Similarly, this can be done. Also, each and every router has been provided with the authentication and password security. We can also use password security in server side, but since we are taking it from external side and we don't want our department users to access the server side, we have used and gone by SSL configuration. So this is it. Thank you. And this is our complete project.